Hello everyone, I'm Li Hao, and today we're going to do Advent of Code 2020. So Advent of Code is a series of programming challenge just on the Advent calendar. So every day from December the 1st until December 25th, there will be one programming challenge, and inside there will be two parts. So solving each of the parts gives you one gold star, and throughout this challenge, you will get, the aim of it is to solve all of the puzzle and get 50 gold star. So today we're going to do day 20. So if this is the first time you're watching this video, you know what? You're losing out a lot. You're losing out 19 videos that we have done so far. So if you want to watch them, click here. The link is over here. Watch them, please. Go and watch them, and let's come back to day 20. So we are at day 20, and let's take a look at our calendar and what is the challenge for today. Day 20, Jurassic Jigsaw. The high-speed train leaves the forest and quickly carries you south. You can even see a desert in the distance. Since you have some spare time, you might as well see if there was anything interesting in the image of the mythical Information Bureau satellite captured. Well, after decoding the satellite messages, you discover that the data actually contains many small images created by the satellite camera array. Well, the camera array consists of many cameras. Rather than producing a single square image, they produce many smaller square image tiles that needs to be assembled back into a single image. Well, each camera in the camera array returns a single monochrome image tile with a random unique ID number. The tiles, which is the puzzle input, arrive in a random order. So worse yet, the camera array appears to be malfunctioning. Each image tile has been rotated, flipped to a random orientation. So our first task is to reassemble to the original image by orienting a tile so that they fit together. To show how the tiles should be reassembled, each tile's image data includes a border that should be lined up exactly with its adjacent tiles. All tiles have this border, and the border lines up exactly when the tiles are both oriented correctly. Well, the tiles at the edge of the image also have this border, but the outermost edges won't line up with any other tiles. So in this example, you have the following tiles, and we need to align them. So rotate, flip, or rearrange. Find this square arrangement that the edges lines up. So this lines up. Right, and okay, so once we line them up, for reference, ID of the tiles are this. So to check that you have assembled the image correctly, multiply the IDs of the four corner tiles together. If you do this with the assembled tiles from the example above, 1951, 1171, 3079, and 2971 gives you this number, which is the answer. And we are going to solve this. So we're going to assemble the tiles, and we're going to multiply the corners of the ID, and then that will be the answer. So let's head to the puzzle input. We're going to save this file as input, and I am going to copy it, move it to the code, and create a new file, code day 20, and we're going to okay, so first thing is we're going to take a look at the input. So tile, and then a tile image, tile image, right? Okay. Okay, so we're going to import fs equals require file system, read file sync, day 20. Content.split line, new lines. Okay, so now we're gonna look through these tiles. Okay, so because we're gonna flip and rotate the tile, so probably I will be creating a tile class that stores the tile information. So this will be the tile map, tile tiles data. Okay, call it data. So this dot data equals to data. And hopefully we will also want to implement a method called orientate. Probably give it an orientation. So this would do the rotate, flip, if necessary, rotate and flip, right? I think there will be 8 different kind of permutations. So 1, 2, 3, 4, fully rotates, and then you flip and then rotates. So flip in terms of the X or Y axis is the same where, so for example, if you 1, 2, 3, 4, 5, 6, 7, 8, 9, if you flip on the vertical axis, you get 3, 2, 1, 6, 5, 4, 9, 8, 7. And then when you rotate it 90 degrees, I think you rotate it twice the turn, you will end up, so if you rotate half a circle, then you get then you will end up yeah, correct. Then you will end up actually flipping the x-axis, right? So flipping in any axis is the same. So there will be rotate. So there will be 4 different kind of orientations for rotate and flip, and then you get another 4 orientation for rotate, right? So we're gonna do that later on. So orientation would be probably what are orientation, right? So switch orientation will give us like 1 to 8. So so 8 different kind of orientations. We'll figure out it later. So let's collapse this. So we have the tile, which constructed with data and probably with the ID as well, so that I know the tile ID. This dot ID equals to ID. Right, so once we have the tile class, then probably what next is to parse that information out. So we're gonna have let line index equals to 0, while line in lines line index less than -1. Less than lines dot length. We're gonna parse the information. So let's see. So first line is tile, right? So so we're gonna have line index dot match tile, right? TILE, and then we capture the ID. Tile ID. And then we have this tile map, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, and I believe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 by 10 grid. So over here we'll be saying, see, we'll get line slice line index plus 1 and line index plus 11, I think. Yeah. This will be the data and tile data, and then we will create a tile class. So const tile equals to new tile number, tile ID, and the tile data. Right, and probably we're gonna store it somewhere. I will be using a tiles array. So tiles.push tile. Okay, and then then we're gonna line index plus equals to 12, I think 12 lines, right? So 12 lines later is this. So let's take a look at the tiles that we have. Node code day20.js. Right, looks good. We have quite a few tiles over here. Right, so once we have the tiles, next what we want is we need to get the edges of the tile so that we can arrange them. Right. So the edges of the tile, I'm gonna represent it with array. So it will be 4 edges, and the position will be 0. So this is like the tile. So 1, we'll save 3. I think like this, 0, 1, 2, 3 on clockwise. Right. So this is like one tile. This is the 0 edge. Then this is the 1 edge. This is the 2 edge. And this is a 3 edge, right? So we're gonna get the edge and then store in a variable so that with the edge we can quickly compare whether 2 tiles edges are same. So what we're gonna do here is actually we're gonna abstract it as a string. So we do string comparison. That will be slightly easier for us to code out. We do string comparison to compare whether these edges match with another edge of another tile. So first we need to come up with the edge first. Right, so edges we have see. So the first tile, this one is actually this dot data what's that? First sorry. It's the first row of the data. And then I guess this is also like this dot data this dot data dot length -1. Oops, and then edge 1 will be all the last item. So I guess this dot data dot map map row dot length -1 dot join, and lastly is the edge 3, which is the first character for all the rows. Right, so once we get the edges, and next okay, so next is to fill up the map, right? So right now let's see what's the length of this. If 144 tiles, which means we're going to arrange them by 12 times 12 grid. Right, so that 12 times 12 grid, and then we get the it's a square. Okay, and then we get the corners, right? So we're gonna have a 12 times 12 map equals an array. Gonna create an array first for cons let's I equals 0, I less than 12. Okay, we create create a map with 12 items in it, 12 arrays in it, and we are gonna fill them out. So to fill it up, we are going to fill it exhaustively or recursively. So here is how we're gonna do, right? So we are gonna try out one by one, fill up the tile map one by one. If we can't fill up that particular slot that we're looking at with all the tiles that we have that hasn't been used up, then which means that we reach a dead end. We can't continue anymore. Then we will backtrack until we can find another tiles that we try another tiles to put it in, right? So this is like a exhaustive search with some backtrack and pruning. So I'm gonna call it fill and then position. So I'm gonna call fill with position 0 at the start, And so how I'm gonna do here is that I'm gonna loop through the tiles of tiles. I'm gonna put the tile if, and then I'm gonna orientate the tile in all 8 positions so that I can try put in any position. So I equals I less than 8, I plus plus. Let's say tile oriented I, right? So I'm gonna orientate the tile, and then if, so now is when I want to see whether I can place the tile or not, right? So let's see. So now I'm gonna put the tile at this position. So I need to know in the row index and the column index of this position, right? So column of equals to position multiplied by 12 and const row position divided by 12 math.floor. So if row is equals to 0 or row I'm gonna see the tile of, okay, how about this? I'm gonna say if can place tile which is the tiles and the position. Right, if I can place a tile in this tile and in a position, then I'm gonna say placed equals to true. So I'm gonna set it placed to true so that I won't place it anymore. So it's like if tile.placed, continue over here, right? And then I'm gonna fill position +1. Right, and what that means is that cannot, then I'm gonna place false, and then we continue, and then so that if, okay, so if I can fill, then return, so fill should return me true if I can position it somewhere, and then if I can fill it in and then return true, right? And over here, I'm gonna possibly return false because if I reach the end of it, most likely I couldn't place this tile anymore. I can't find a tile that I can place. And over here, the base case would be if position is equals to 144. That means we reach the end and return true. So it means that you have placed all the tiles. So you still need to fill this in, which is can place tile. Tile and position. So we can use this over here instead. So can place tile at the position. So we get a position that we want to place at. So if column is greater than 0, which means that we have one column on our left, then we're gonna see whether the left ones, the tile on the left can align with the edge that we are looking at right now. So if column is greater than 0, then the left tile equals to tile column, wait, row first and then column -1. Yep. And then if left tile dot edges, okay, so now we want to see the right edges of the left tile. So right edge is 1. I'm gonna say 1, right? So let me copy this down again. So left edge is 1. So left edge is if left edge is not equals to the tile dot edges left edges of the current tile, then I'm going to return false. Right? If there's tile on the left and couldn't align, then return false. If row is greater than 0 and top tile, so this is the top tile, so we're gonna row -1 and current column. And if the top tile edges, which is bottom edge, which is 2, does not align with my top edge, then return false. And I can return true immediately over here. We don't have to compare the right tile and the bottom tile because we are placing tiles row by row and column by column from the top left all the way bottom right. So most likely the bottom right does not have any tiles at all yet. So we can fill, then it's true. We can place and then, okay, so once we say place and then we call fill, but before that we also need to actually place the tile. So this is when you have the, okay, calculate the row and column again. So you're gonna have the row and the column equals the current tile. Right, so we're gonna place one by one, try it. If possible, return true. If not, we then keep rotating and keep trying different kind of orientation. And then once we find once we can place all the tiles in, and return true, and all the way this is going to return true and return true all the way to the top. Right, so once we do a fill, then the answer will be fairly straightforward. Would be doing a tile map 0 and 11 dot id times map 0 0. Okay, so this is on the top left and top right, and then map bottom left map 0 11 11 dot id. This is the bottom right. So you can console this will be the IDs, right? So now we are going to look at a tile, which is the last thing that we're going to do is to orientate them, right? So I'm going to split into two halves. So first is that the first one, case 1, is actually doing nothing, right? So I think I should save this as the edges privately, and I gonna set it only when I actually do the orientation. So this one will be edges 0 1 2 3. So doing this, I don't have to worry about mutating the edges, because next when I try to rotate, I will mutate it. I'll mutate this dot edges, will change it, right? So I still preserve this edges, the original position. Yeah. So let's take a look at it here. Case 2 is going to rotate 90 degrees, so it will end up become 1 2 3 and 4 5 6, right? 1 2, oh sorry, so 1 2 3 4 5 6 7 8 9. So this is rotate clockwise 90 degree. So what this means is that the edges now would become so 1 2 3. So this is still 1 2. Okay, let me paste this in over here. Right, so 1 2. So the left be this as well. Okay, so yep, so the right edges now is 1, 2, 3. So which is the originally the top edges, right? So this dot edges 0. And then 7, 8, 9 is actually previously the second edges, right? So this is over here. And then for the top is 7, 4, 1, which is actually reverse of the original left. Original left is 1, 4, 7, now it's 7, 4, 1. So this is this edges edge 3 dot reverse. I think you can't reverse a string, so I'm gonna split by empty and then join them back. I guess better I implement it as a function. So reverse string return string dot split reverse dot join. Right, so this is the reverse of this edge. And here 963 is a reverse of 369. So this is reverse of edge, previously edge 1, right? So one edge down, and let's take a look at the next edge. So orientation 3 is we're gonna rotate this again. So then we will end up with 3, 2, 1. And then 6, 5, 4 and 9, 8, 7. Right, so this, okay, I think I need a brick over here. So this is originally okay, this dot edges. This is now top and left, top bottom are reversed, and then 7 and then 1, 7, 4, 1 is also reversed, right? So three edges, all the edges are reversed order. So we have these dot edges 2, and then we have edges 3, then we have edges 0 and edges 1, 2, 3. This is previously 2, this is previously 3, previously 0, previously 1, and all of it 3, 2, 1, 1, 2, 3 become 3, 2, 1, 3, 9, 6, 3, 3, 6, 9 become 9, 6, 3, 7, 8, 9 become 9, 8, 7, 7, 4. So all of them are reversed. Yep, and another edge down, and let's take a look at the fourth edge. Right, lastly, fourth edge is 8, 9, 8, 7 here, and 6, 5, 4 and 3, 2, 1. Right, so so as you can see here, 3, 6, 9 and 1, 1, 4, 7 are preserved, right? So probably you might spot some pattern over here, but I'm gonna just continue and do it through. So I'm gonna say this dot edges 3, 6, 9. Okay, 3, 2. Oh, sorry. 1, 2, 3, 0. Okay, and then this edge is preserved. This is reverse. Right, and then we are going to do orientation 5, 6, 7, 8. So orientation 5, 6, 7, 8. So here is that we are going to look at this one. So I'm going to flip on the y-axis instead. So as you can see here, what happens is that we're gonna flip out the edge, the second and the fourth, edge 1 and edge 3 we're gonna be swapped, right? So edge 1 and edge 3 are swapped, and then the top edge are reversed. Top and bottom edge are reversed. Okay, and let's break this and let's continue. Whew, this is tough, man. So now we rotate. So this will be 3, 2, 1, 6, 5, 4, and 9, 8, 7. So 3, 2, 1. So the first edge is so the first edge is edge 1 and edge 1, edge 0, edge 0, edge 3, and edge 2, and then see 3, 2, 1, 9, 6, 3, 8, 2, 9, 8, 7, and so they're all reversed over here. Okay, and then let's move on to the next one, which we rotate again. Whew. 9, 6, 3. Then rotate see 9, 6, 3, 8, 5, 2, and then 7, 4, 1. Right, this time around we gonna move this up, right? Edges 9, 6, 3. I believe it's 1, 2, 3 at 7, 8. Okay, so now 7, 8, 9 and 1, 2, 3 are not flipped, which is the first one and this one. And then we're gonna do our final orientation. This time round would be a 7, 8, 9, 7, 8, 9, 4, 5, 6, and then 1, 2, 3. So this time around, I'm gonna shove it up, right? So 1, 4, 7. Okay, so 1, 4, 7 is not reverse. 7, 8, 9 is not reverse. 7, 8, 9 is H2 initially, right? Yep, and then 3, 6, 9 is not reverse, and 1, 2, 3 is not reverse. Okay, then we are. Phew, that is it, and let's run this, right? So, sorry. Let's run this. Left tile row. Okay, so probably we get something here. Floor position divides by 2. So when fill, we are going to fill in map row tile. Row minus left tile. Okay, let's see what is the row value. Wait, tile row 0. Okay, let's see. Come down and let's see. Map 1. Right, we have 12 empty rows. Oh man. Okay, now I know. Okay, I spotted. Okay, so this is supposed to be the map, not the tile. And do I type it correctly? So let's see. Tile edges 1 of undefined. Left tile edges. Edges. We define all the edges over here, right? Edges. Okay, so once you call the orientate, edges should be defined. Let's see, we have 1, 2, 3, 4, 5, 6, and 8. I know. So I think we should call it from 1 less than 8. Okay, let's try it again. Whoops. Okay, firstly I remove this first, and then let's see what we are calling the field position. Oh, we are filling up. Oh, actually we are good. So let's clear and let's run it again. Okay. Feels like we are getting a number, and let's try it out. Wow, yes, that's the right answer. And let's go to part 2. Part 2. So now you're ready to check the image for sea monsters. The borders of each tile are not part of the actual image, so we need to strip off the edges. And in the example, the tile become like this. Remove the edges and remove the gap. Okay. And now you are ready to search for a sea monster. Because your image is monochrome, the sea monster will look like this. When looking for this pattern in the image, the space can be anything. Okay, so just focus on finding the hash sign, a pound sign. So only the pound need to be matched. Also, you might need to rotate and flip your image before it's oriented correctly to find the sea monsters. In the above image, after flipping, rotating it to the appropriate orientation, there are 2 sea monsters. Okay, marked with 0. Marked with an O. Okay, so determine how rough waters are in the sea monsters habitats by counting the number of hash that are not part of a sea monster. So probably once we mark out what are the cells that are sea monsters, we count how many hash sign, and then we're gonna minus off that. So how many hash are not part of a sea monster? Okay, let's go. So now once we find out the orientation, we find out how we can fill this thing up, then probably we're gonna actually seal the deal of the orientation, right? So previously we are only orientate the edges. It's much simpler, but now it seems like we need to flip and rotate all the cells and all the rows as well. So let me take a sip. So probably we need to store this orientation information in the tiles. so that it will remember the last orientation that it was being called, and hopefully that will be the one orientation that it should be, the final orientation. Okay, so now what we are gonna do is that, let's see, I'm gonna actually orientate the cells, the data, right? So I think we can keep this for the sake of like finding the orientation, but after that we need to I call it like a final orientation, final orientate. Okay, I can finalize. Okay, so now we need to, firstly we need to strip off the edges, right? So this gives us like a this dot data is equals to, probably not even call it data, so I could just call it I know, now I'm gonna call it get orientated data, right? I'm gonna call it results. I'm gonna return the results, right? Or rather orientated data. Okay, so I'm gonna call this so that I can get the orientated data, which is already stripped off the edges and rotated correctly in the correct orientation. So here I'm gonna say gonna strip off, so this dot so initially it's going to be this dot data dot slice 1 and this dot data dot length as 1. I'm gonna slice off, and then I also need to map line see, gonna map, gonna let the slice 1 and line dot length minus 1. So now we strip off the edges on all sides. Next is we need to rotate, flip if necessary, right? So now we're gonna get back all these things again. And okay, I'll copy this out. We'll switch. Okay, so now we're gonna switch the current orientation, this dot orientation. So let's see. One, two, three, four, five, six, 7, 8, 9. So this one remains this. This is gonna return this is gonna do nothing, break. This we are going to see, every line now is every line here is the original column but reversed. Okay, original column but reversed. So orientation data equals to oriented data equals oriented data dot map. See, is it a map? Column. Okay. Phew. Let's see. I'm gonna call it a result first. Equals to an array. Let I equals to 0, I less than orientation data dot length. So now we are at each row each row is the column data reverse, right? So result dot oriented data map line I dot join with an empty array result dot push oriented data. So get each of the line, each of the column, and then oh, I need to do a reverse, and I'm gonna join them and I'm gonna push in. Okay, orient. I'm just gonna assign it back to oriented data so that we return it in the very end. Right, so one case down, and let's move on to the next one. Okay, so I think this is pretty handy. I'm gonna copy it over as well. Okay, so this one is 9787654, which is 97654, which is the original data in reverse and all the rows reverse. Right, so oriented data dot reverse, right, and then dot map line dot reverse as well. Okay. Okay. Now the next one would be I think this one. I'm gonna copy this again. So 9, it's again, this is every row is the columnar data, but in reverse of the position. So we're gonna three six nine, right? So this is no longer I, but oriented data. The length minus I minus 1, right? Because the length is 12, 12 minus 0 is 12, but we want the 11, right? So it's off by 1. Map over here, and also 369, and then 369258. So we're not reverse it. I think this is okay. Okay, so we are done with this. And let's, are you still there? Are you staying strong? And let's move on to the next one. So 3, 2, 1, 654, and 987. So this is all the rows being reversed, right? So I think it's pretty similar to this one. Except we don't reverse the order. Okay, this one down. I believe the case 7 is similar, so I'm gonna do that first. 3, 2, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's just reverse, and that's all. Okay, and then 6 and 8 would be probably similar to this case, so I'm gonna copy this data over here. So 6 is actually doing a 3, 2, 1, 6, 5, 4, 3, 2, 1, 9, okay, 9, 6, 3, right, which is 8, 5, 2. Nine, 6, 3, 8, 5, 2. columnar and then reverse, right? Okay, and then last but not the least, case 8. I'm not sure if there's something wrong, how I'm gonna figure out where I went wrong. This is rough. So let's just push it through first. 147, 147, 147, 285. So this is the 0 and no reverse. Okay, and so this will give us the orientated data, return the orientated data. So once we fill up everything and we are done with it, probably we need to copy it to the bigger map, right? So bigger map, which is 12 by 12 times 12 map tile, and each of the tile is 10, right? Okay, never mind. Let's see, final map. Create a final map, and we're gonna copy all the tiles in. So we're gonna use it, do a for loop. I less than see, the tiles are 12 by 12, so we're gonna 12 by 12. Do a J. Okay, so final map. This will give me the tile, which is the map I and J. So I'm gonna copy the tile data, right? Data equals to tile dot get orientated data. And over here, once we get the data, we're gonna copy it over to the final map. So let's see. I think we can start with the final. Okay. If I is 0, okay, we need to create an empty arrays for it first. So if I equals to I is the row, right? For each row, yeah, if I equals to 0, we create some empty row first, which is final. Let's k equals to 0, k less than 10. Okay, so this is another variable where I'm gonna say so for every tile there will be there will be 8 rows in the oriented data. So we're gonna pre-create, like, for every, this is for every tiles. So for every tiles, or for every 12 tiles, 12 rows of the tiles, for each one we create 8 empty rows in the final map so that we can fill it in first, right? So this will be I times 8 plus k equals to empty array, right? With empty array, with an empty string, right? So over here, then final map of, okay, so we also need to copy every row. So same thing here, I times 8 plus k will be equals to this plus the data k, right? So then we'll keep appending new string inside. Console log final map. Now take a look at how it looks like. 158. Okay, so I need to create a scope. I create a new date. Create a new block because the result is block scope and the block of this is this block. So you can't redeclare the same variables again in the same block. So we can create a new block so that it's actually declaring within the block. So I run this again. Okay, so this is a bit weird. One, two, three, four, five, six, and 8. Okay. I think no way. So this is not just the first. You need to do it for every tile row, right? So once we do this, okay, we have a map. I'm not sure how I can verify this, but hopefully this is correct. Yeah, hopefully this is correct. So orientation. Okay, so now I need to once I have the final map, this is like a big tile, right? So I can create the final map tile equals a new tile ID we're gonna see 0 and datetime is gonna be the final map, right? So this is the big tile. So we can still do orientation. We can still orientate it and we can still get the orientation data, and then I'm gonna try 8 different orientations and find whichever has the sea monster, right? I think as long as there's one sea monster is the correct orientation. I'm guessing that will be the aim of it. So I'm gonna say, okay, I'm gonna copy the sea monster in. So here I have the sea monster. Okay, please fill. Sea monster. Right, I have the sea monster here with me. And then so I need to basically try every orientation. And okay, so we're gonna have orientation goes to 1 orientation less than equals to 8 orientation. And for each orientation, we are going to final map tile oriented. I get the orientated data for the final, for the big tau, and I'm gonna loop through to find the sea monster. Okay, so we're gonna do a loop I less than 0, I less than oriented data, length, I plus plus. Actually, this can be less than minus C monster dot length. And then again, j equals to 0, j less than orientation data I dot length, and we can actually less than C monster's length as well. And then, so this is ij position that we start looking, find a map for the sea monster, and then we actually need to look through the sea monster to verify that it matches it. So let's sea monster I equals to 0. Sea monster I less than sea monster dot length, and sea monster j just sea monster I dot length. And finally, we're gonna say if sea monster I, sea monster j is a hash sign, and the one that we're looking at, which is orientation data of I plus this and j plus this, is not a hash sign, then we're gonna continue finding the next position. So continue finding. So finding is in this loop. So this is the loop that we find on every I and j position to find out whether it has, and then the inner two loops is to loop through the sea monster I and j and see whether it's actually mapping it. If it does, then I'm gonna say over here is that count plus plus, right? What that means is that let's count equals to 0 and count plus plus, right? And so which means we already found one sea monster, and I'm gonna console log count. So here I am going to copy the example over here, and this to see whether we have done it correctly so far. So I'm gonna come here and I'm gonna paste this in, because according to the whoops, what? Did I change something? I thought we, hold on. So, oh, okay, I think we have lesser, okay, so tiles, 9, right? Only tiny tiles. So this is size, map size equals to math dot square root of tile dot size, tile dot length, right? So over here, let's see, 9 index This is still okay. Okay, so here, map size over here, map size over here. Sea monster is okay. These are okay. This one is the map size. Okay. Phew. Okay, let's try run this again. Oh, tile. This is tiles.lang. Only one sea monster? Oh no, there is two sea monster. Which is not correct, right? Huh. Okay, anything could go wrong, but let's take a look at the final map tile first. Okay, so let's compare with the one given. Oh wait, it's the same, right? It looks the same. Wait, this part is not the same. It looks almost the same except this part of it, right? It seems like the last row is correct. Or rather this tile is incorrect. This tile itself is incorrect. Well, okay, so probably one of the tile has a certain orientation and it's not the right orientation. So I'm gonna say this is the map, right? So I'm gonna call console log map. So this should be this orientation number 8 is incorrect. So let's see orientation, and I guess no one has orientation 8, right? Yeah, that's why. Okay, so orientation 8. Okay, so orientated. This should be I. Now it looks correct, and 2, which is correct. Okay. Phew. Okay. Luckily, it's not too much a big deal. Remove this, remove here, and we're gonna come back over here, count. Okay, so the final run. Okay, so we found sea monster. It's ++. We also need to remember where sea monster is. Whether I'm not sure whether sea monster will overlap, right? That's it's not mentioned, but let's just to be safe. Let's record all the sea monster position in. Right, sea monster. So this is like I know for sure that sea monster exists. So I'm gonna say it's like gonna have sets. And I'm gonna record all the sea monster position at and sea monster position is this one, right? Okay, I have all the sea monster position, and the last hoorah will be loop through the orientation. Sorry, not orientation. I loop through the map, the final tile mapping again, and then count number of hashes. I think before that also we need to see, probably to be safe also, once we found that one of the orientation has data, and we'll just break here. Right. Okay, so now for each orientation data and orientation data length, let's total hash equals 0 if orientation I and j is hash total hash plus plus, and the console log total hash minus sea monster position dot size. Okay, so what orientation? Oh, okay. 227, which is what? No, that are not part of CMOS. Hold on a sec. Orientation data. Two five seven. Oops, it's even less than. Let's see. What could be wrong? Orientation data total. Hold on. Probably you can't call this too many times. Slice this data slice. Okay. So let's just see what we are getting over here. Oh, okay. I think I know why. So, if you look at the map that we printed out earlier, it's slightly longer and slightly wider. So it seems like we trimmed the final tile map edges as well. That's why the hash has less edges, right? So I think we can come over here and see. We can, okay, I think we can call a trim edges over here instead. Okay, and what we're going to do here is we're going to actually trim it. So this data is trimmed now. And that's orientation data is just based on the data. And we can trim edges only when we need it, which is here once we fill up the whole thing. And before we come over here, before we get the orientation data, probably we're gonna call tile.trim edges, right? And okay, so let's clear this and console again. Yeah, I think now it looks more reasonable. 273 is the answer and it's correct. So let me remove any log from here on, and let's replace this with the actual input that we are going to solve. And let's run this again. 2304, and let's paste that in. Yes, that's the right answer, and that is for day 20. So if you like this video, give me a thumbs up. I know it's a very long one, Thank you for staying so far. If you have any things that you think I can improve on, comment down below, and let's see you on the next day. So please subscribe my channel so that you get notified when the next one is out. So see ya, bye bye.